Okay, well, this is the second video B for the fourth section of the trigonometry. That's and this bit's on trigonometrical equations. So we've been having a look at the identities and how we resolve identity problems in part A. So now we're going on to look at trigonometrical equations. Now, very often the questions are, the way they're asked is you have to resolve some identity. And having done that, then you use that resolution, actually an alternative statement of an expression or an equation, and then you actually convert it into a form that is solvable as an equation. Okay, so if we can just cast our minds back, I'm assuming you've watched that video, and the sort of equations that give rise to, well, there are all sorts basically, but there are some common ones that crop up quite a bit. And the first one is what I would call a single factor equation. So it's something like this. You might just see it as 3 sine 2x equals 1, for instance. But we could think of it as a single factor, and that equals 0. So therefore 3 sine 2x equals 1. So that is one form. Now we might get a 2-factor equation. Here we've got two things multiplied together equaling 0. So we can solve for this first one and solve for this second one, and the solution sets are basically combined for those two. Now, in amongst all this, remember that when we're looking for solutions to things like sine 2x, or 3 sine 2x equals 1, sine 2x equals a third, then there are multiple solutions. So we have to look at the range of solutions that are required and sort of choose our solutions accordingly. Okay, so that's single factor, that's 2-factor. Now, a special case of the 2-factor is where the trig ratio that we've got in both factors is the same, because this essentially is a quadratic equation. So it's a very common kind of form of equation solve. Yeah, we just solve it like a quadratic. You may not see it like this. You might see it as 6 cos squared 3x minus 7 cos 3x plus 2 equals 0, or something like that. But of course, as a quadratic, we would just solve it as in the same way. The other time tend to see 3 sine 2x plus 4 cos 3 sine x plus 4 cos x equals 2. So this is a linear sum of sines and cosines. Now, not quite so obvious how to resolve for this one, but what we do essentially is we convert this into a single function, so either sine or cosine, and we choose which is more appropriate or which we're required to do. Now, this really is in the area of we're into the area of transformations of trig graphs, and also something called the R formula. It's widely called the R formula because that alludes to the process that we use for solving these equations. So we're going to touch on that and develop it a bit more in another video. Now, there are other types of equations, and I've got the odd example there, but but these are the sort of main ones that I'm kind of concentrating on in this video. So let's just have a look at a 1-factor equation here. Then this problem here. Let's get that down there, just out of the way. Solve for this range. These always include some range, 0 to 360, giving your answers in degrees to 1 decimal place. 3 sine x plus 45 equals 2. All right, so as a single factor, you could say it's 3 sine x plus 45 minus 2 equals 0. But we can easily restate it like this, and as such, of course, we can write it as sine x plus 45 equals 2/3. Now, our first step is to solve for x plus 45. So we're just treating this as the unknown angle, and if we go through that, we find our primary solution. We can find this off our calculator. Is 41.81, and then we have another solution, which of course is 180 minus 41.81. So if you cast your mind back to the lesson on symmetry and periodicity, and that's what that gives us, and that's 138.19 degrees. So so those are our kind of first two, if you like, and then we've got these, add 360, add 720, and so on. So I've added 360 to each of these. I've got 401.81 and 498.19. So that's sort of given us 4. But I note that when we subtract 45 from this one and this one, we're going to get something which sits outside the range that we're interested in. Whereas subtracting 45 degrees from this one, 138 and 401, actually leaves us in range. So we're going to get rid of those two, and that's going to leave us with these two solutions, which I notice I've expressed as 2 decimal places, but hey ho. So it's 93.19 degrees and 356.81 degrees. So that's an example of a single factor. Okay, another one here. Well, very, very similar. Solutions of 2 cos 3x equals 1 between 0 and 360. So yeah, cos 3x equals a half. So 3x gives us this solution set. So these are the kind of start with 60, then we want 360 minus 60. Is that. And then we can add 360 and then 720 to all these. Now, it is important actually to kind of stretch your range out, particularly if you've got, say, something like 3x here, because we know then we're actually going to be dividing all these angles by 3. Okay, so once we've done that, we've got this set of solutions here. Okay, so that is the solution for that. Now, if we go on and have a look at some 2-factor solutions, let's have a look at this. Show that the equation this can be written in that form, and hence solve this equation here. Right, okay, so this is exactly what I was talking about before, is that we're not going to solve this like this. It's going to be a bit difficult. What we need is it in this sort of 2-factor form here. Okay, so first of all, we have to resolve the identity. Again, a similar one to this in the last video. Tan 2x is going to be sine 2x over cos 2x. So if we cross multiply the 2x, cos 2x, and we get this, and move everything onto one side of the equation and factorize it, then we get that. If you're not convinced to that, you can just pause the video and just check that, but that's what we have. So this is what we're going to solve. So it says hence solve this, and sometimes these things say hence or otherwise. Even if it says hence or otherwise, it's nearly always the hence, and in this case, it's the only show in town. We've got to use the thing that we've actually done in part 1. So so to solve this equation, then basically we solve this equation. Simple as that. That's it. So what do we do? All right, okay, we've got 2 factors in this. So we're actually looking at either 5 cos 2x equals 1 or sine 2x equals 0. But now for this first one, then that's going to give us 2x equals the arc cos of 1/5. So 2x is this solution set here. Have a look carefully at the ones that we're actually going to use, but in this case we're only going between 0 and 180. So that's going to give us 2x equals these two values, and therefore x is half of those as those two values. So those are the solutions that apply to the first factor. Second factor is slightly more straightforward, sine 2x equals 0. So therefore 2x equals 0 degrees, 180 degrees, 360 degrees. And therefore x equals 0, 90, or 180. Okay, so so those are therefore the solutions. Notice I've missed up 90 off the bottom here, but we've got a solution set made up from these 5 solutions here. Okay, so that's how we do a 2-factor, and in this case, what I've done, I brought it right through from the sort of the resolution of the identity. So 2-factor quadratic in this case show that the equation that can be expressed in this form. Well, again, we did something similar to this in the last video. Let's just assume that that has been done. So we're going to solve this equation. So in order to solve this equation, we're going to solve this equation. Okay. And to solve that, then, well, what I've done here is you could do this. It's, quite convenient. So I've just denoted cos x as c. So we can just write it with a bit of shorthand, saves a bit of time, doesn't it? Explain what I'm doing there. And then we factorize that using the exploding the middle there, and we're going to get cosine 2x equals a half from that factor, or cosine 2x equals -3. Now that's that is not going to give you anything, is it? But fear not. I mean, this is the nature of these things. Is that, yeah, this quadratic, this might, c equals -3 might be a solution to this quadratic, but it's not actually a solution to the problem because it's infeasible for the problem that we're talking about. Cosine of anything goes between -1 and 1, so that's infeasible. So we can jettison that one, and we're just left with this one. So cosine 2x equals a half. So 2x equals, 60 or 360 minus 60, and then 60 more than all of these as well. So that 423, 60 plus 360, 660, 300 plus 360, and so on. So that's 2x. So therefore x is going to be half of all those, and all those are within the range that we are looking at. Okay, so that is how we do that. Right. Okay, so those are the first so the kind of the 1-factor, 2-factor quadratic, which is, say, just a specific case. I'm going to close that video there. I think we'll do this formula 1 in a separate video. So I look forward to seeing you then.